Hello, welcome to Module 4. Let's go ahead and jump into our learning objectives this week. This week's topic is really focusing in on conceptual understanding in mathematics and how the heck we teach conceptual understanding to our students. So we have a lot of students in our classroom today that if they're going in the field of engineering, architecture, or things like that, they have a really strong, deep sense of what concept knowledge is in mathematics. Students who are not going in those areas particular because they just don't have a strength, that's where we have to come to play and be like, what can we do with our teaching to really get them to understand these concepts so that other things in their life can be meaningful to them? So, as you know, the primary thing that we need to do with conceptual understanding for our students is to be able to give them the tools to understanding the information and the generalization so that they could apply to real world activities. It is very difficult because there's such a variety of complex concepts. The best approach to developing that understanding for our students is using the concrete, representational, abstract instructional process. It is one of the best ways to promote conceptual understanding of math. This process, of course, begins with the concrete level. Concrete level is where you are having your students themselves use dramatization and or 3D objects to demonstrate specific concepts. Dramatization, is where you're having your students physically act something out. A great thing that I've actually had my students do to understand integers is I actually had them line up, get up in the room, and I had a piece of masking tape that ran straight down my room. And I had it kind of marked off with numbers. And what I had was I used it just like I would a number line. And I had students all start on 0. I had them take steps forward, meaning that they're increasing and going in a positive direction, to understand that numbers are positive. And then I had students take backward steps, and we use that as negative integers. So every single time a student went forward, that was positive. Anytime a student went backwards, that was negative. I can't tell you, even my students who had cognitive disabilities totally grasped that concept because they physically got up and they visually saw what happens when they go forward versus backwards on that number line and why that is. Especially if you throw up an algebraic problem where you're saying 5 minus 2 versus 5 plus negative 2, they can clearly see the difference of what that means. Okay, next, depending on the age and interest of students, it may be way more appropriate to begin that concrete level instruction with manipulatives versus the students acting it out. I know sometimes our kids are a little shy to act things out, so it's better sometimes just to use manipulatives. It is so helpful to use different manipulatives, though, during each of our type of lessons so that they get an idea of generalizing concepts. Not using the same thing every single time to describe a triangle. Using something different is very important. Concrete level instruction that includes verbal descriptions, observations, dramatizations, and hands-on experiences with three-dimensional objects helps students understand and develop mental images of math concepts. When students demonstrate understanding of the concepts at a concrete level, they are ready to move on to the instructional process where it shifts to that representational level of instruction. At this level, students see how drawings or pictures can be used to represent mathematical problems. There's been a great deal of research out there, and some researchers have noted that 3 lessons at the representational level that consist of approximately 20 problems each is a sufficient way for many students with mathematical disabilities to master conceptual understanding of initial place value, including ones and tens, basic facts, fractions and equivalencies, etc. So basically, by having them physically draw something out, they have a better understanding of visually seeing it and to what it means. The goal of this type of instruction is to help students deeply understand math instead of simply memorizing procedures and answering with no meaning attached. It is that deeper level of understanding that allows our students to be very successful in understanding math and making those generalizations, like I said, for that real life situation. Conceptual understanding is, once that is obtained, the instructional process then shifts to the abstract level of instruction that involves solving problems without using anything, without representation, without manipulatives, without acting it out. Abstract is just abstract, it's out there. To provide and to promote that, you have to provide a really deep foundation of understanding and the meaningfulness behind why you're teaching students these different concepts. It helps them to make sense of the operations they perform and provides them with the depth of understanding that expands beyond, like I said, that recall and that basic recognition. It really gives them the opportunity to practice higher order thinking and makes subsequent learning easier. So for our students who have disabilities, by doing things like this, making it fun, making it creative, helps our kids who are struggling with the concepts to get it. It's really important that we usually use higher order thinking skills with our GT kids, but you could actually use higher order thinking skills with your students who have cognitive disabilities. Don't set that expectation low, set it high, but give them the tools for them to understand it. Students exhibit conceptual understanding through at least 4 cognitive processes: application, noting relationships, transformation, and transfer. And to look more about what each of these mean, I refer you to go back to page 69. That not only does it describe it for you, but it gives you really great examples of what this looks like for promoting that conceptual understanding. What are the steps that you have to take when we are planning and implementing our instruction? In the book, in Hudson and Miller, it promotes a few key things that I think all teachers should look at, and once again, not just for math, but for other topics as well. We first have to consider their prerequisite background knowledge. And in math, as you know, it's very it has a hierarchy to it. You have to start at basics and then you build from there. If we miss and we have gaps in between, that's why our kids, once they get up into algebra, geometry, algebra 2, calc, etc., have a very difficult time because their foundation isn't solid. There's so many gaps. So if they never understood fractions, they're going to have a heck of a time understanding how to do algebraic or geometry type of problems if they don't have that when fractions are in their upcoming problems or problem solving. Considering appropriate structure for teaching specific concepts. A huge thing to pay attention to is that teachers must also consider what type of materials we're using to get this part of the structure in place. So when you're using compare and contrast, if you're showing longer and shorter, you might want to have manipulatives that actually demonstrate that. Or if you're doing equivalent fractions, what would be a good tool to use for students to understand that? Examples and non-example structures, I know that sounds a little silly, but for example, you could use where you're giving them a demonstration like this is a nickel, it's worth 5 cents, and then you show them a picture of a quarter and say, this is not a nickel. And let's talk about why this is an example and this one is not an example. And that's also a good compare and contrast activity to do as well. Step-by-step process is really great for our students who need things to be chunked down into smaller pieces to understand the whole. And so if you're even teaching, I know the book gave an example of multiplication where they first look at a number, count how many plates, if they're putting them on plates, then they are going to add cubes to each plate to represent the numbers within each group, and then they're going to count it as a total. That's a physically way of kind of putting it in pieces. So first we're going to start with setting up our groups, then we're going to set up how many are in each group, and then we're going to add it up the total. So that's a step-by-step way for them to process, to be like, okay, 1, I have to do this. 2, I have to do this, etc. Consider oral language is huge. Math vocabulary, most of our students who really struggle with math, it's because they just don't understand what it's asking. If you throw out to a student, hey, I need you to understand distribution. Well, without them really understanding what the word distribution means, they're probably not going to be able to solve a problem asking them to do that. But if you give them an example and really teach them the vocabulary of what that means, the next time they'll be able to see a problem, they'll be like, oh, that's right, I know how to do that. So glossaries are fantastic. I sometimes find students where they make a glossary in class, they have the term, they have an example. That's all fine and dandy, but if they don't really use it as a tool, that's not going to help them. So we really have to build on that math vocabulary. Some of you may have heard of standout math. For the younger kids, I've talked about this before. Standout math allows students to talk about vocabulary but put chants behind it so that they understand what those terms mean. Especially for our students who have significant language issues outside of just having math issues, it's so crucial that we build this vocabulary. And students who are even ELL, it's huge because they might be coming and might know it in Spanish, but they cannot relate it due to the concept language within math or the concept language within science. They might have a real difficulty with that because of the actual terms. It is really important when we're choosing in math, and sometimes it's very important for students to realize that times and multiplied, regroup and borrow and carry, minus, subtract, take away, sum, total, answer, one's place value versus one's column, those are things that are all, they have similar meanings, but they use it in different ways. In some textbooks, it might call it times. In other textbooks, it might call it multiplied. It's important for us to give our students the tools to know that those are the same things, and we have to use the same language, especially when solving problems. Word problems are really tricky because it can change the language on a student that they might not be familiar with. So it's key to know what that oral language looks like for the student. The next is consider various modes of representation. So it could be what it looks like with a manipulative, what it looks like with the pictures, a visual display, written symbols, a real world application. All of those things are very important with ways of how we can get this across to our students for them to really understand what we're talking about. So, what is the concrete abstract continuum and how should we implement this approach? Well, the first thing is always when we're teaching a new concept, I find it to be very important to start with the concrete and build. Now, you might not need to do that for every student, but you would find even your high advanced kids might have a better understanding of something if it's concrete, where they can physically interact with it. Plus, I personally think concrete is a fun stage of doing things where you could be silly and have hands on time to actually get up, move around, have some kinesthetics, do something outside of the box for our students to understand something, and then progress, as we described, to that abstract. On the next part, the question is, what are the specific examples of effective teaching in mathematical concepts across the curriculum? So it's a great strategy to use. I do, we do, you do. You've heard that tons of times. It's a strategy that shouldn't go out the window. It's a fantastic strategy for the students to feel that confidence because they see you do it, have that confidence that we're going to do it together, and then before I practice it on my own, I have a good idea of what I'm doing before I get to just here's my worksheet and I've got to suffer and figure out how to do problems completely on my own. Advanced organizers are fantastic. Advanced organizers allow your students to have a pictorial, verbal or written text, verbal and graphic organizers. It gives it to them in a way that it's not just one way of teaching. Advanced organizers include three primary components. One is review of prerequisite knowledge, as we've discussed, especially with letting them know what's up and coming is also important. Statements of what the objectives are. What do I want you to get out of this today? It doesn't need to be a mystery. I want you to be able to tell me what place, if I give you a number, I want you to be able to tell me what each number in that number means and what the place value is. It could even be also the third thing is that rationale for learning the new concept. So why are we learning this? Why is this meaningful? Why is this relevant to my life and how can I apply it? That's crucial. The I do modeling, as it talked about in the book, talked about the three M's: the demonstration, model your thinking, and maximizing that engagement. There's also monitoring the student's understanding. So we can't just spit something out at them without figuring out if they're getting it, if they're in it, if they've got the buy-in, and making sure that they really have that understanding behind it. The we do approach really gives them that extra support, and that's crucial. What are the components of excellent explicit teaching? Well, as we discussed in chapter 1, that whole phase where it goes around, this taps in directly into the explicit instruction piece, meaning how are you telling the students what they need to get out of what you're teaching them? So go back to that chapter 1 if you need a refresher on what those phases of the explicit teaching cycle are. That reminds me, the word for this week for your password that you need to write down and send to me is the word explicit. So please send the word explicit to me. Okay, next is what are the strategies for improving the effectiveness of components of explicit instruction of students with diverse learning needs? And I'm going to go right back to that 3M model. It's the model, it's the maximizing, and it's the monitoring. If you use that simple system where you're showing your students, you're getting their buy-in, and then you're monitoring to make sure they get it, that is the best way to really work on your students with diverse learning needs. You can do it in a variety of different ways, as we've discussed: giving pictures, having them physically get up and do something, having them draw a picture, whatever it may be. That is going to help your students, no matter what their learning need is, to really get them to understand a concept. If you don't monitor and you're not checking for understanding, then you're not going to know if they're really getting it or not. A lot of times when I'm instructing, I'll think an idea is great, give it to them, and they look at me like deer in the headlights. I'm like, okay, got to have plan B. Always having plan B or plan C, other ways of demonstrating or showing a student how to do something, is crucial, especially if you have a co-teacher in the room who has a different way of doing it. That's where co-teaching is just like the perfect thing, because then that other teacher could come in and be like, okay, what about this? And you never want to give too much where a student's going to be confused. How can you enhance problem-solving abilities with your students? I will tell you, if you give them a good, strong conceptual understanding, they will be able to understand the vocabulary, they will be understand the concept of what they're trying to get across, and be able to basically demonstrate for you in a variety of different ways what that means. They don't have to necessarily write down a number. It could be a picture, it could be a drawing, it could be acting it out for you. And those are great ways for students to demonstrate for you what they know. I hope that helps. If you have any questions in regards to conceptual understanding, feel free to email or give me a call. I'd be more than happy to help you. I hope you got a lot out of this module, and we'll see you for next module. Take care.